Hi everyone, today we are going through the next chapter, which is on level annuity. So first, what is annuity? Annuity is basically regular series of payment. Okay, so for example, we have rental. So basically rental usually is a monthly series of payments, right? And insurance premium, that is usually also monthly or annually. Car loan, monthly. Pensions, maybe annually or monthly. So you get the idea. It's a regular series of payment with a sum pattern, and the payment interval is fixed. So this one, there's example, the payment period is 1 year. So this is an annuity of $100 payable at the end of each year for 10 years at 5% effective rate. Okay, now I want to introduce to you two types of annuity immediate and annuity due. Okay, this is the illustration. First, we look at annuity immediate. So what is annuity immediate? It is basically a regular payment, and each payment is paid at the end of the year. So for the first year, the first payment is paid at the end of that year. For the second payment is paid at the end of the second period. Okay, so this annuity have 10 payment. First payment until the 10th payment. So there's 10 payment, and each payment is paid at the end of the year. What about annuity due? Annuity due, for this example, also there are 10 payments, but the first payment is made now, and the last payment is made at time 9. So every payment from that 10 payment is made at the beginning of the period. So for the first year, the first payment is made at the beginning of that period. Okay, so now you already recognize the difference between annuity immediate and annuity due. And also I want to highlight that if you want to see the difference between these two cash flow, it's just this part. So for as I said, both of these have 10 payments. So if you want to compare, annuity immediate don't have any payment at time 0, but annuity due have. And for annuity immediate, it have payment at time 10, but annuity due don't have. So the difference between them is the first and last payment. So now let's see the detail of the annuity immediate and annuity due. So again, annuity immediate, first payment is due at the end of the first payment period. Annuity due, first payment is due immediately. So it's really ironic, because when you see annuity immediate, you expect it to be due immediately, but no, annuity immediate is at the end. Only annuity due is due immediately. Okay, eventually you get used to these terms. Okay, so there is a common notation that we use. So to get the present value of a level annuity of $1 for n years, and it is annuity immediate, this is the term. We call it A angle N. So for example, just now our example, this technically if we write it down, it becomes A angle 10, because there are 10 terms and the payment is 1. So you just like 1 times, but we don't write it. Usually when it's 1, we don't write it as 1 times angle 10. But usually if the payment is something else, then it will become payment times that A angle N, which is PV. Okay, so the present value is A angle N. And for the annuity due, if you want to find the present value of this cash flow, these 10 payments paid at the beginning of the year, the present value is A double dot angle N. Okay, now you know the term. So for this A angle N, how do we want to find the present value? What is the present value of this regular cash flow or this annuity? Let's look at the first one. Okay, the present value of this, let's see, there are 10 cash flows, so you need to sum up the present value of all of these 10 payments. Okay, what is the present value of the first payment? Present value of the first payment is 1 times you have to discount 1 year, so v to the power of 1. So since it's 1 times, you just don't need to write that 1 times. Okay, so the first payment, the present value at time 0 is going to be v to the power of 1, because you need to discount it 1 year. What about the second payment? What is the present value? You need to discount it 2 years. So how do you do it? Plus v to the power of 2. And then the third payment, v to the power of 3. And so on and so forth. Until the 10th payment, it is 1 times, you have to discount it 10 years. v to the power of 10. Okay, so it is also equals to the sum of when t start from 1 until n, v to the power of t. So this is what we got here. I made a mistake here. It should be 1. It should start with 1. Okay, so you can calculate it like this, but if you have 10 terms, you will take a lot of time to do this, to calculate it like this. So instead, you can also find the present value, A angle n, with this formula, 1 minus v to the power of n over I. Okay, just recognize this formula first. We will understand how it is derived later. For the accumulated value, we write it as S angle n. So this is the, if we are looking at this illustration, S angle n means we are evaluating this cash flow where the annuity is paid at the end of the year, but we are now evaluating it at time n. Previously, when we find present value, we are evaluating at time 0. So when we evaluate at time 0, we are doing A angle n. But when we are evaluating at time 10, we are finding S angle n. Same goes to annuity due. When we are evaluating at time 0, it will be A double dot angle n. And if it is evaluated at time n, not at time 9, okay, it's at time n, time 10, then it is S double dot angle n. Okay, now what is the formula for S angle n? It will be 1 plus I to the power of n minus 1 over I. So if you notice, this is v to the power of n is PVF, as this one 1 plus I to the power of n is AVF. I hope you recognize this. Hopefully by recognizing that, you can remember this formula easier. Okay, now for annuity due. Annuity due, as I said, the notation is A double dot angle n, and this is the formula on how to calculate the present value of annuity due. So how do we get that? Let's see from this illustration. So from this illustration, you see present value of this cash flow, the first payment is 1 at time 0. So since we are trying to evaluate it at time 0, so the first payment, we don't need to do anything. We just take 1 as it is. We don't need to discount or accumulate it to evaluate it at time 0, because it's already at time 0. Okay, so the first payment is 1. The second payment, what is the present value at time 0? You need to discount it 1 year. And then this one, you need to discount it 2 years. So on and so forth until this payment, which is at time 9. So we have to mark plus v to the power of 9. So it's equals to, this one you need to add from t to ni, and t equals to 1 until tn minus 1, vt plus 1. Okay, so you can write it using this first principle, you can calculate the present value, or you can also just memorize this formula. So it will be 1 minus v to the power of n over d. So if we compare with annuity immediate, the only difference is the denominator. So for the accumulated value, this one, if we write down the notation is S double dot angle n. So if you see the formula, it's the same with annuity immediate, except for the denominator. It's d instead of I. Okay, now moving on. Derivation of the annuity formula with geometric progression formula. So this is geometric progression. Geometric progression happens when the next term is equals to the previous term times a common term. So in this case, our common term is R. So the previous term is A, right? So next term will be previous term times a common term, R. For this one, the previous term times common terms, R. So on and so forth. Okay, so that is geometric progression. So how do we sum up all of this for n number of terms? So there are n terms here. This is the first term, and then this is the nth term. Okay, to sum it up, this is the geometric progression formula. It is A, which is the first term, times 1 minus R, which is the ratio, the common term, to the power of n, which is the number of terms, divided by 1 minus the common term. So if you see again, it will be as follows. First term times 1 minus ratio to the power of number of terms, divided by 1 minus ratio. Okay, hopefully that is not so hard to remember. So now let's try to apply that geometric progression formula onto our first annuity. So this annuity is illustrated as follows. It have level payment of 100, and then it is annuity over 10 years, and it is paid in arrears, which is an annuity immediate. So the present value of this annuity, you can write it as follows: 100, which is the level payment, times our annuity immediate formula. I hope you recognize this. 2 times n. So this is the present value using the basic principles. You are just discounting every single payment 2 times 0. Okay, now let's try to use geometric progression to sum up this term. Okay, what is the first term? We want to apply this formula, right? So what is the first term? The first term here is 100V. 100 times V, that is the first term. Okay, so it's 100V, that is the first term. And then times 1 minus ratio. What is ratio? Our ratio is the difference between the first term and the second term is V. That is the common ratio. So 1 minus the common ratio is V to the power of number of terms. So number of terms, there are 10 terms here. So 1 minus V to the power of V is the ratio times number of terms. And then divide by 1 minus common ratio. Once you get the formula, you can simplify. So 1 minus V, you know what is 1 minus V? It is D, right? Or D, you can also write it as I over 1 plus I. Okay, so you cut this 1 plus I and you cut this 1 plus I, because 1 plus I times V is 1. Okay, so when you cut that, you are left with like this. You are left with the following: 100 times 1 minus V to the power of 10 over I. Or you can also write it as 100 is the payment times 1 minus V to the power of n over I. If you recognize 1 minus V to the power of n over I, that is the formula for A angle n. So what we are writing here is also payment times A angle N. Okay, so or in other words, our payment now is 100, right? So it's 100 times A angle 10. Okay, now let's do more exercise on the geometric progression. Let's say you have this calculation. You have 1 and 1 plus 1 plus I until 1 plus I to the power of 9. So the common term is 1 plus I, and then number of term is 10. And then do the formula with geometric progression. So the first term is 1. So the first term is actually, for this case, the first term is 1 times 1 minus the ratio is 1 plus I to the power of number of term 10. Okay, and then divide by 1 minus common term. Okay, so I hope you can see that. And then when you do that, you can rearrange. How do you rearrange to become like this? If you calculate this, 1 minus, so at the here you will get negative I, and then here you get 1 minus 1 plus I to the power of 10, right? So but we don't want this negative, we want it to be positive, so you just you just switch these two, and then you get this formula. I think okay. And then now you actually what you just did is you are finding the S angle N. Without noticing it, you are actually finding S angle N. And for this one, if you do the geometric progression, what do you get? Recognize the first term times 1 minus the common ratio to the power of the first term, divide by 1 minus common ratio, and then you simplify, and then you get this. Okay, so without knowing, you are actually calculating S double dot angle N. Okay, you will have a look at it later. Try to practice your geometric progression formula from these two examples. Okay, now I want to illustrate how come that formula just now was actually finding the future value for annuity immediate. So let's see. This is what we calculated just now. 1 plus I until 1 plus I to the power of 9. Okay, what do you think this comes from? So when we are calculating S angle N, we are evaluating it at time 10. Okay, so this one is which payment? Okay, it will be this payment. Okay, the payment of 1 at time 10, evaluated at time 10. You just don't do anything, you just take it 1 as it is. But this one, this is from which payment? It's from this payment, the ninth payment. So to evaluate this specific payment at time 10, you have to accumulate it by 1 year. So accumulate it by 1 year, you times by 1 plus I. And then this one at 5th year. 5th year, if to evaluate at time 10, you need to accumulate it 5 years, and so on. So your last term will be this payment. This payment you have to, the first payment you have to accumulate it to time 10. So you need to accumulate it by how many years? From 1 to 10, 9 years, right? So that's why the last term will be 1 plus I to the power of 9. Okay, I hope you recognize that. So annuity due is also the same. So the other calculation just now, we are actually doing annuity due, right? So this is the formula that we calculated just now with geometric progression. So let's see how we derive that from this illustration. So 1 plus I, which payment is it? We are also evaluating S double dot N at time 10. So this one will be which payment? This payment. So we are just accumulating it by 1 year. And then the last term is this payment. And this payment, you need to accumulate it by how many years? Into 10 until 10? 10 years. So that's why it's 1 plus I to the power of 10. Okay. Alright. So, if we don't use geometric series, we already know what is the formula for A angle N and A double dot angle N. I hope you remember this already by now. Okay, so it is 1 minus V to the power N over I. Okay, if we want to derive S angle N from A angle N, what you need to do is just you apply the principle of equivalence like this. AVN equals to AV0 to the power of times AVF. And the AVF is as follows. Okay. So if we do it, this is the A angle N times 1 plus I to the power N, then you will get this. Same goes if you do accumulated value. So that's why sometimes, especially when you go to the more complex annuity, you don't need to memorize both formula for present value and future value, because you just remember the present value and you can easily derive the future value. However, for the S angle N and S double dot angle N, I suggest you memorize the formula right away, because it will be very convenient. Okay. And another relationship between annuity due and annuity immediate, it is as follows. Annuity due is annuity immediate 1 year from now. So when you accumulate an annuity immediate by 1 year, you accumulate by 1 year. When you multiply, you are accumulating by 1 year, right? So you will get annuity due. So interpretation of this relationship is, in 1 year time, n term annuity immediate is going to be n term annuity due. For example, this is an n year annuity immediate, or specifically it's 10 year annuity immediate if we evaluate it at time 0. But if we are evaluating it at time 1, so this becomes annuity due. Can't you see? Because when you are evaluating at time 1, the first payment is, this will be the first period already. At time 1, this will be the first period. This one will be the second period. This is non-existent. Okay. So the first payment comes here. And the last payment comes here. So, if we change the time of evaluation, then from annuity immediate, this cash flow becomes annuity due. That is the relationship. So this is a very useful relationship. So for S angle also is the same. In 1 year time, the immediate version will become a due version. Alright, moving on. Relationship number 2. Okay. A double dot angle N is equals to 1 plus A angle N minus 1. What do we mean by that? Let's look at an illustration. A double dot angle 6 is equals to 1 plus A angle 5. Okay, so let's look. The red one, 1 is here, this payment. And then A angle 5 is this payment. The green one. So you add the red and the green, you'll get A double dot angle 6. So you have 6 payment paid in the beginning of each year for 6 years. Alright. Okay. So that is relationship number 2. Relationship number 3. This is also a relationship between annuity due and annuity immediate, but this one is related to S angle instead of A angle. So for S angle, it's pretty much similar. So S angle N plus 1 is equals to S angle N. Sorry, this one is not angle. S angle N plus 1. S double dot angle n plus 1. So, for example, S angle 6 is equals to S double dot angle 5 plus 1. So, 1 is this last payment, and then S double dot angle 5 is this green payments. 1, 2, 3, 4, 5. 5 payments in the beginning of the year. Okay, I already color coded it properly so that you can see it. So S angle 6 is equals to 1 plus the S double dot angle. Okay, S double dot angle 5. Okay, moving on. Okay, this one I just want to show you that when even before this we already see, right, annuity immediate, 1 year from now it will become annuity due. So when you see a cash flow, for example, when you see this cash flow is a bit unique. It is the payment start at time 5 until time 12. So there is 8 years of payment, 8 years of level payment. So we can see this as an annuity immediate because it is paid at the end of the year. So this is the 5th year, so it is paid at the end of the 5th year, right? And this is at the end of the 6th year, 7th year. So we can see this as annuity immediate, but we cannot say that, oh, when it is paid at the end of the year, it will always be evaluated with annuity immediate. No, because as we seen earlier, whether or not it will be annuity immediate or in annuity due, it depends on when is it evaluated. So for example, if we are evaluating this cash flow, these 8 payments, if we are evaluating at time 4, then what will it become? It is an 8 payment and it is evaluated at time 4. So this is just simply A angle 8, because the first payment come 1 year after the evaluation date. But if we are evaluating it at time 5, then what does it become? It is still present value of all of this cash flow, but at time 5, so it will become A double dot angle 8, because the first payment due immediately. What about if we are evaluating this cash flow at time 12? So what is this? Are we going to find S angle 8 or S double dot angle 8? Okay, if you see our illustration just now, when we evaluate S angle, both it evaluates at time n, but for annuity immediate there is a payment at time n, but for annuity due there is no payment at time n, because the last payment is paid 1 year before that. So when there's payment at time n, that is, we are going to use S angle n. But if there is no payment, the last payment comes 1 year before, then we will use S double dot angle n. I hope you understand that. But so for this case, this 8 payment, if we evaluate it at time 12, it will be S angle 8. There's no double dot. If we evaluate it at time 13, the last payment comes 1 year before, then it becomes S double dot angle 8. Okay, now